Hey guys, this is Joe again. I'm going to go over the same problem we just went over, finding the voltages VA and VB. However, this time I will find what the currents are after finding what the voltages were. So we're interested in the original problem in the book, which was asking what the current source was, and we needed to find that. Basically, they used a different method, doing an equivalent circuit using a wide delta transform, and I can show you guys that after this. However, let me go ahead and just show you, just to reiterate and to put in your head how to find currents and what the current source versus what the current demand is. So in this circuit, we're actually demanding a lot more, but you can tell that all this node, like we said, is exactly the same. So the current flowing in here is going to actually go, there's a node where basically we have a resistor here and a resistor here, and then that resistor here, like that's the 30 ohm. This one would be like that 10 ohm, and that one would be like the 12.5 ohm. So basically we have a current going in, and it splits out in 3 different directions. Now, since current flows from high to low, basically what that means is high potential or high voltage to low voltage. This is 0 voltage and this is 120 volts, so your currents will more than likely flow in these directions that I showed. Okay, so let's get started. We already had mentioned earlier that basically the current through the 30 ohm resistor was easy to find because it has a potential difference that we don't need to know what VB or VA is in order to find that. So we already know that this current I30 is going to be equal to 120 over 30, which is actually equal to 4 amps. Okay, so what goes in must come out. So basically what that means is if this is the current source here, the current source has to be equal to the current through the 12.5 ohm resistor plus the current through the 10 ohm resistor plus the current through the 30 ohm resistor. We already said this is 4 amps. Now the same will go with I10 and I12.5. So basically the I12.5 would be 120 minus VA, which is 70.82. And we're going to divide that by 12.5, and that will give us our current through the 12.5. Now the current through the 10 is exactly the same. You got 120 minus VB, which is 74.75, and that's going to be over 10, and that's going to equal to I10. So basically if we add all of those currents together, we should get the current source, whatever that's trying to tell us it is, and that's 120 minus 70.82. Divide that by 12.5, and then you're going to add that to 120 minus 74.75, and you're going to divide that by 10, and then we're going to go ahead and make sure that these are in brackets to make sure the difference. Make sure when you're putting them in the calculator you're not just doing 120 minus 74.75 divided by 10. I just made that mistake for some reason. Don't use the calculator much. So 120 minus 70.82, and then we're going to divide that quantity by 12.5, and we're going to add that to 120 minus 74.75. We're going to divide that one by 10, and then we're just going to add 4. So basically I got the current as being 12.459, so about 12 IS is about equal to 12.46 amps. And let's see if does that work. Well, we'll find out. 12.46, if we open up LT Spice, I already have that running. At this point we have a 3.93 plus 4.52, so just ballpark, that's around 4. This one's around 4.5, that's about 8.5, and this is 8.5, so that's about 12.5. Yeah, we got 12.46, so that should be correct. Let's see if it actually gives us the current here. Yeah, 12. So it's minus in this case because we're supplying the current, but it's exactly 12.646 about, and that's what we got. So that's the correct answer. Alright guys, in the next video I'll do the same exact problem, except for what we'll do in this case is we'll do the transform that they recommend that you do in the book. I would also probably recommend it if you're just trying to find the current. If you're trying to find the total resistance, you can technically find it by here because we have a voltage source and we also have a current source. So we should know what the R equivalent is because voltage source divided by your current source should be equal to R equivalent. So if we have 120 divided by 12.46, your equivalent circuit, just 120 divided by 12 is about 10, so you're going to be looking at 9, probably like 9 point something. So 120 divided by 12.46 is equal to 9.63. And in the book, what do they get? I don't know if they actually have an equivalent. Yeah, 9.632 is their equivalent in the book. So we know that should work out. Alright guys, well I'll show you what they do in the book next. It's tedious. Honestly, I could do the same exact process I did using KCL and show you guys how to derive the equation for Y delta transformation. But I'm not going to do that because it is really tedious. So again, watch the next video. It'll be on Y delta transformation. If you have any questions, please leave them in the comments, and I'll talk to you guys later. Alright, thank you.